are really honored to have one keynote speaker with us who is going to be called one of the 25 hot influential speakers by the National Speakers Association, I think. He's one of the most influential people in digital marketing, and this was an award given by a leading digital marketing magazine, and author of books, and he's very influential and a great storyteller, so we are very honored, and I'd like to welcome you to Jim Sterne over here. Thank you.
One of the wonderful things about that presentation is how it's based on research. I appreciate that very much because I'm not a research kind of person. I'm fascinated by technology and I like to jump into it so early that there is nothing to research. I wrote my first book on online marketing in 1995. The one on artificial intelligence in marketing was from 2017. So I ask a lot of people how they're using it for marketing and they say, not yet. So I get to invent stuff instead of actually interview people. So thank you for doing the hard work. And I agree with everything you discovered. So I feel more confident. So the robots are coming. Marketing is about to get really weird. And it's going to be pretty exciting. So I want to walk through all of that. It's not going to be robot zombies with lasers. Don't worry about that. When you look at stuff that looks like science fiction, it's science fiction, right? I do not believe that HAL 9000 will kill the crew to save the mission. I don't think Sonny from iRobot is going to kill his inventor to prove to the world that robots are bad. And I don't think that the Robin Williams character in Bicentennial Man will be granted citizenship. That's science fiction. This, however, narrow AI, functional AI, is doing interesting things. But first we have to unpack the word because it's at the top of the hype cycle. Anything that we really don't think a computer can do must be artificial intelligence, right? So, natural language processing. It can understand that the noise you're hearing now is speech, and this is not, and so it ignores it. That's pretty cool. It does that well. It translates speech into text and text into meaning, so you can actually have a conversation with a machine. That is AI. Computer vision, being able to look at a picture or a video and determine what's in it, is artificial intelligence. And of course, self-driving cars and robots, because robots, we love robots. But machine learning is part of all of this, is the stuff that we care about. Because this is the stuff that we're going to have to do marketing in a world that has all these things in it. But machine learning is what we care about. So let me offer my layman's perspective, definition, and it's about software. So I'm assuming everybody in here has written some sort of line of code at some point. I started on BASIC, Fortran and COBOL, yes, I am that old. And it just does exactly what you tell it to do, line by line, step by step, until something goes wrong, and then it gently kicks out an error, unless something goes horribly wrong, and then all hell breaks loose. So that's just software. Now, a mathematical model lets you put in formula and variables and change things around. Okay, Excel spreadsheet. And you get to iterate to see what the results are. What if we had 10% more here? Or what if we change that relationship? And out comes the answer at the bottom. So you get to play math. Statistical analysis, oh, okay, yeah, you actually do want an advanced degree for that. It is a lot more sophisticated. And it just says, we're going to look at the data as it exists, and we're going to predict where it's going to go. Great, very straightforward, pretty complicated, rules-based, and still, like the Excel spreadsheet, we're doing iterations. We're going to build a model, see how it works, and if it looks like it works pretty well, we'll try to use it to predict things, and we'll take action based on those predictions as long as it keeps working, until it doesn't. So George Bach said, all models are wrong, some models are useful. And all models, I add to that, all models have a limited lifespan, because the assumptions change, the marketplaces change, the competition changes. Then we get to this machine learning thing, which looks at the data and uses the examples from the data to build its own model, and then updates that model as new data comes in. It has the ability to change its mind. So we just give it data and tell it to find something in there, and it creates structure that can predict, that can take action. Because intelligence is the ability to adapt to change. Something you can do really well, a computer can't do very well. We call it intelligence. Well, let's talk about it a little bit. Okay, so how many data scientists in the room? Okay, great. You guys can take a nap. I'll wake you up like that. This is the super simple for marketers explanation of machine learning. Actually, stay awake, because when you talk to marketing people, this will be useful. It's like how simple you gotta get. 3 kinds: supervised, unsupervised, reinforcement. Big, broad categories of machine learning. Supervised is you know the answer, and you're giving the machine lots and lots of examples so that it can learn the answer. Yes, that's a dog. No, that's not a cat. Yes, those are my friends. Do you want to label your friend? Yes, you just taught the machine. Thank you very much. I want the machine to recognize a cat, so I've got to give it a ton of labeled data. Here's a picture, but I have to label it. That's a cat, that's a cat, that's a cat, that's a cat. Machine looks at it and says, well, what do I see in common? It's got these pointy things on top. It's got these almond-shaped, call them eyes, and they're all kind of looking in that direction. What the heck is that thing? No idea. Now, a child will go, well, it's a kitty cat. Yeah, it is. Because kids, much smarter than machines. But I've got to give it a lot of cats for it to recognize all of that stuff. Because frankly, is it a cat or is it a croissant? That's kind of hard to tell. Is it a chihuahua or is it a muffin? I'm not sure. So that's just for humans. The machine has more problems than that. Machine says the difference between a wolf and a dog. Okay, I need labeled data. Where do I get it? Google Images, right? Thousands of pictures of wolves and dogs. So you feed that into the machine, it's labeled, and the machine says, okay, I see that there are some differences, that's fine, and that is a wolf. No, but I understand why you think so. It's actually a husky. Pretty close to a wolf, but it's not a wolf. Okay, well, this is definitely a wolf. Wait, what do you mean? Well, every other wolf picture, the thing is standing in the snow. So clearly, it's a wolf. It's not reason, it's statistics. This is what CAPTCHA, how many layers CAPTCHA has to go through just to recognize the letter A. It needs a lot of data to make something that's super simple to us. So that's supervised, you know the answer. Unsupervised, don't know the answer. You just have a bunch of data and you give it to the machine and you say, tell me something interesting. Tell me something I don't know. Categorize things. So just put my customers in buckets by whatever means you need. Look at all of the attributes and cluster them. Here are my customers. Go out into the world and find people who look like those folks. Identify 7 categories of customers I have so I can treat the messaging differently. And oh yeah, find the thing that doesn't belong. Really good at that, right? So it's, I don't know the answer, here's a bunch of data, find something for me. You don't know if it's the right answer or not, but it finds a correlation. It's not good at analysis, it's good at correlations. So online buying goes up when the weather is bad, like this morning. Yeah, people don't go outside. So that's true, but I actually knew that already, so it didn't help me very much. Ice cream causes drowning. Absolutely. Ice cream sales go up, drowning goes up every time. Absolute correlation. The cause might be something else that the computer doesn't know about. Shoes cause headaches. Now this I know personally. Because every time I wake up in the morning wearing my shoes, horrible. Maybe there's something else going on that's causative, we don't know. But Nicolas Cage is a monster. This I have proof because the number of people who drowned by falling in a swimming pool and the films Nicolas Cage appeared in, perfect match. Clearly, he's a monster. Correlation, causation. Machine's great at correlation, so let it do that thing. Supervised, I know the answer, and I'm teaching the machine. Unsupervised, I'm just looking for input. Reinforcement says there's actually no real answer. It's just there's behavior that I want to reinforce. Sit, stay, good boy. The activity I want to reinforce is less spam bounce backs, more opens, more click-throughs, more conversions, and the machine will try to go toward that goal. And when it does, it gets a numerical reward, and it does that action again to try to please master. So I know the answer, I don't know the answer, there's an outcome I'm looking for. Where might I use that as a marketing person? Here is what customers look like, and here are visitors to my website that have never bought anything. So tell me out there, who are the people who look like my customers? These are high customer lifetime value. These are people who call customer support and return items, and if I can identify them and predict them, I will send them directly to my competition. Oh, these people are calling in, maybe it's for tech support, but maybe they're going to cancel. So if it's for tech support, send them to the techies. If it looks like they're going to cancel, then I'm going to send them to the sales department for the people who are really good at retention. In reinforcement, the activity. I just want more of the same. Okay. So now we get a little data science-y, but just a little. This is how a marketing person with a degree in Shakespeare describes machine learning. Stay with me. Decision trees and random forests. Decision trees you're actually accustomed to, you just don't know it. Decision trees are really good at classification clustering. The machine is brilliant at dividing things up. So we look out at the world and we say, how do we separate things? Well, first by gender. So let's just split them. Now, I'm from California. I know there's more than two, separate conversation. Then we're going to divide them by age or location or recency, frequency, etc. And by the time I get down to a specific leaf, I have a very unique group of people that I can target with a unique message that's very different from what I'll send to that person, or that person. So I'm segmenting for behavior. Okay? Real world example. Had a neighbor who sold motorcycle insurance. And one day over dinner, he told me that obviously males buy more motorcycle insurance than females. That's a given. But then the best indication of risk was, do they park it inside? Number one, if they do, they have a garage to park it in, so that's income. Number two, chances are excellent. If it's in the garage, it is a midlife crisis motorcycle and not a teenager tearing up the neighborhood motorcycle. Now, when you get more data than that, that's just too many things for a human too many variables. So give that to the machine and let it chew on them, okay? So great at this tree thing, decision tree. Now, if I take something simple like A/B split testing and apply this to it, that's the same offer, isn't it? But it'll get different results from different people. But the machine can say, you know what? The people who fell for A, when they hit A, this many people hit A1, this many people hit A2, and then we can subdivide, and now I have a unique group that I can give a unique message and get a specific lift. So this is something that humans can do with spreadsheets and data entry, and it would take too many humans too long. Even interns eating pizza for their pay would take too long doing this. But the machine, no problem. Computers are fast, accurate, and stupid. Humans are slow, inaccurate, and brilliant. So when you hear artificial intelligence, think augmented intelligence, and that's where the power is. You use them both together. Computer's never going to come up with this one. Buy one beer for the price of two and get a second beer free. I'm going to that pub. I want free beer. Always want free beer. Computer's not going to do that. So what if I take a decision tree? What if I take a bunch of decision trees? Now these aren't random decision trees. The randomness is how they are created. So I'm going to randomize the data samples and I'm going to randomize the variables. Here's what I mean. Here is my data table. The rows are individual people, the data. The columns are the attributes about those people. So I'm going to take my data set and randomly choose individuals and randomly choose attributes for that tree, and then I'll create another one and a whole bunch of them, and they'll all come to a conclusion. This is the power of more than one. It's like why diversity in the workplace is so valuable, because all of these decision trees are thinking about it from a different angle. And the solution they come up with is better than any single decision tree by itself. This, then, is a random forest. So when you hear a data scientist talk about that, you can go, by golly, I know what you mean. All right, support vector machine. These don't get talked about very much, but I love describing them just because of how visual the description is. Here's my data set. I want to create an algorithm that will divide the blue from the green. Not hard to do. Done. Except that I've got a couple of vectors here that are right by the line. So confidence is pretty low. I'm not really sure. So I want to find a way to increase confidence. I'm going to write a slightly more sophisticated algorithm that cuts this way and increases the margins between the two colors. Confidence goes up. Yay. What if my data looks like normal data? I could write an algorithm that divides the blue and the green, but my confidence is going to be absolutely 0. If I look at it in 2 dimensions. What if I look at it in 3 dimensions and I turn it, and then I turn it a little more, and I turn it a little more? Now I can draw a straight line that divides the blue and the green. Split it right down the middle. Simpler algorithm because I looked at it in 3 dimensions. The fun part is, computers are not limited to 3 dimensions. It can think about many dimensions. I cannot display many dimensions. Multi-dimensional support vector machine image on Google gives you a bunch of interesting stuff that's not very meaningful, but it is to the machine. Because it can look at it from so many different angles, it can categorize things that you couldn't otherwise. Okay, so, support vector machine. But this is what's getting all of the attention. The deep learning neural network. Okay, so first thing to know. This is a model of how we think the brain might work. We don't really know how the brain works. We guess. So we took that guess and turned it into software. Now here's what it does. It takes 3 inputs to a neuron and kicks out an answer. My example is, should we go to the movies today? Well, the first question is, what's the cost? I want to go to the world premiere of Captain Marvel. That's going to be in Hollywood, California. It's going to be pretty expensive. Probably not going to go. Or the weather. This afternoon, not so bad. This morning, no, we're not leaving the house. Or how much effort? I have to get a babysitter. I have to make sure that the dinner is prepared for the kids. I've got to make sure that we've got parking. You know what? It's just a headache. I don't want to go. Any one of these can overwhelm the others and kick out a no. But generally, it's the normal movie theater. The weather's fine. The babysitter is available. Great. Let's go. So those are the 3 inputs to the one neuron. Now let's add another layer. The hidden neurons. The hidden neurons are, well, the last time we went to the movies, she broke a tooth biting on popcorn that hadn't been popped, and we got in an argument in the parking lot, and the last time we went, it was a romantic comedy, so that means I could get to go to an action adventure, but you know, that broken tooth, I'm not even gonna bring it up, so no. But none of that is spoken. I don't even know that I'm thinking it. It's happening back here. It's a hidden layer. So now I take a whole bunch of hidden layers and let the machine figure out what layers are important to come out with a final decision. And here's where it gets fun. This is where the data science is actually heavy lifting mathematical science. Because if the machine says that's a cat, and I know it's not, I tell the machine, you're wrong. Why did you think that? Oh, well, it was this node that caused the decision to say it's a cat. Well, why is that node confused? Oh, because it got this input from that node that got that input. Oh, here's the problem. So I'm going to automatically fix this problem so that the outcome is, no, it's not a cat. And that is called backpropagation. And this is why I studied Shakespeare. That's the heavy lifting math. And these are problems that data scientists are actively working on. So when you hear people talk about decision trees and random forests, support vector machines, neural nets which become deep learning, now you kind of have an idea of what they're working on and why identifying the problem and looking at the recommendation that comes out the other end is your job, and doing all of this stuff is their job. All right, here's where it gets fun. This is the meta version of all of that. Ensemble. Ensemble says we're going to take what you just learned and a whole bunch of other things and stuff that hasn't even been invented yet. And when you talk to data scientists, there are new papers every week, every month, new methods, new ways to do it. And I'm going to put them all together, and I'm going to give them all the same problem. And I'm going to give them all the same data. And I'm going to let them work out which one is the best method for coming up with a proposal, a recommendation, a solution, a prediction. So it gets fairly meta pretty quickly. And that, to me, is what makes it exciting. The ensemble of all of this high-level, sophisticated math is really good answers, surprisingly. So it's using data to build models of reality and then making recommendations, and when new data comes in, it can change its mind. How does that impact marketing? Well, I can use it in operations. Text analysis of market research. People post things on social media, they send things in email, they answer surveys, and I get a whole bunch of text that I can measure for sentiment and meaning. Audience targeting. What message do I send to what group of people? And let it create messages and try them all out. Now, this is the machine acting like the child learning to ride a bicycle. It rides and it falls over. It rides and it falls over. And then it figures it out and it's gone. It does amazing work. But it does it by making lots of mistakes on the way. It can do creative design. It can take different pictures that you give it and try them all out in various combinations. It'll tell you where to spend that. It'll help you with loyalty management. It can. All of these areas are very specific problems to solve. There is no model that can do any two of these things, and certainly none that will do everything. Each individual one is solving an individual problem at a time. Great at correlation, bad at analysis, right? So people who buy beer in the evening are also buying diapers. People who are left-handed are better bank loan risk. That isn't even logical, but the data suggests that it is. Is it useful? Well, that's for you to figure out. Is what comes out of the system something that's interesting enough to take action? So there are machine learning being built into all these products. Adobe is using Sensei not only for their Adobe Analytics, but also for Photoshop. You can take a picture and it will look at the pixels and determine that that's a tree in front of a mountain, and it can manipulate the picture so that you can change the angle of view because it's guessing what would be behind that tree. So you can take a regular two-dimensional picture and look at it as a 3D picture. That's happening now. It can identify objects in an ongoing video. It's getting smart. IBM Watson. Anybody from IBM in the room? Sort of?
Partner.
A partner, okay. Then you can confirm or deny as you wish. Watson, as we all know, beat the humans at Jeopardy. But now it's baked into everything that IBM does. So a friend of mine who took over the IBM customer analytics team with all the tools that they bought from all the different vendors trying to wire them all together, was told after he was hired, oh, from now on, it's customer analysis with Watson. And he said, well, do I get a data science team? No. Your job is to figure out how to make that promise true. You're going to call it that because everything's Watson now, and you got to figure out how to fold Watson in there. The only thing he could do in a timely way, because it's such a big company, is create an API to weather.com that IBM had purchased just for the data. And that's how Watsonized their analytics system is. It's what I refer to as marketecture. It's integration at the brochure level. I don't know if you're finding out that Watson has great sophistication, but it's really lots of marketing.
Yeah, but it changes already. I mean, they take now stuff out of Watson.
Yeah.
Like, for example, the web clipping, they deleted it totally. I had a client project.
Oh dear. Oh.
And the predictive analytics is now in the Oracle, I believe. So they take it out again.
Yeah.
And it's not that marketing thing.
Yeah. Oracle is doing kind of the same thing. Salesforce has Einstein, which is interesting because it is the Salesforce platform, and you've got your data, and then everybody else has their data, and it's doing analysis across all of those data. That's interesting.
But that's also IBM.
That's Watson, but applied specifically, not just a promise, but actually applied science. Shopify, is that platform known here? Everybody? Okay, good. It's a e-commerce platform with lots and lots of very small shops. In February of 2019, it had 800,000 merchants. They grew by 200,000 last year, or in 2017, so it's on their way to 1 million merchants who get maybe 100 people a day. That's 100 million people, okay? So that's a lot of data. And they created this thing called PIIK, which is a recommendation engine. And it says, hi, Ellen, we've had more than 670 visitors to our store in the last 30 days. Let's start a retargeting campaign to remind those visitors about your product and bring them back to purchase. In order to reach our visitor audience, I recommend a budget of $25 for a 14-day retargeting campaign on Facebook. Can I show you a preview? Yes, no. So first of all, it's doing all of this data behind the scenes across thousands of merchants in order to say, oh, I see a pattern that Ellen might take advantage of. But the brilliance, of course, is the user interface. Because Ellen doesn't even need to be a web analyst or a conversion rate optimization expert or a search person. It's just like, yes, no. So would I like to see an example? Of course. Okay, well, here it is. And oh, by the way, here are the results from yesterday. Would you like to double your investment to $50 as a test? Yes, no. That's machine learning at work, right? And they're going to do it across Facebook and Instagram. They'll help you with your email marketing. They're tying it into APIs with other tools. And for those of you taking pictures like crazy, yes, the slides will be available. So that is operations. That is robots coming to help us do our job. Not take it over, help us do it. But that's not the weird part. This is the weird part. The weird part is saying, Alexa, I need 20 AA batteries. And Alexa says, great, we have Amazon branded batteries, done deal. Unless the manufacturer's done a good job of marketing to me, and I know to ask my, okay, Google, I need Duracell batteries. Because if I don't specify, then Google's going to probably recommend whatever they get a kickback on from whichever company made a deal with them. Unless I am top of mind branded and I'm going to call out your product by name. But what if I want German batteries? And what if I'm asking my Samsung Galaxy S10? Maybe I get German batteries, maybe I don't. So that's a little weird. Then it's going to get even more weird. So voice and augmented reality, because it's a new marketing thing we are all going to be playing with. Look at a two-dimensional object and show it in 3D. Look at a product and show me menus. let me look at your product online and then look at it in my living room, and I'll move it around to see where I like it. So I'm doing this visual thing with augmented reality. Here's facial recognition. What glasses do you think I should wear? Here are the different lipstick colors. What do you think? Click on the one you want to purchase. And it works great until it doesn't. Famous CEO in China, face on the side of a bus, got a jaywalking ticket. Recognized her face, said she shouldn't be walking there, got a ticket in the mail. A little buggy still. Vehicle. Okay, so we're going to get self-driving cars, right? Well, guess what? That's an advertising platform. Because they're not driving. So we as marketers have to figure out ways to interact with that. Clearly, location-based we've been playing with geofencing, but now I can coordinate with the billboards. I can provide specific kinds of entertainment depending on who they are and where they are. I can have the Volkswagen tour through the Alps. You know, just hit the button and we'll take you on this great tour all by yourself. Oh, and delivery. Because in the US, Amazon has this capability of this lock on your front door. The delivery person comes up, hits the button, the camera sees who they are, GPS says where they are, your front door unlocks, they open it up, they leave the package, they lock it, it's all recorded, and now they can do it to the trunk of your car, wherever your car might be. So for marketers, we now get to optimize for delivery capabilities. And working with everybody else who's collecting all kinds of data. So here is a shirt that is checking you out while you work out. This is silver fibers worn directly into the fabric for real-time biometric data, connected up to the black box that talks to your iPhone. Okay, well, what if that communicates with this app that is doing nutrition analysis of what you eat, that is connected to this local restaurant that is all health food restaurant, connected up to your health food store, which is Whole Foods owned by Amazon, that's connected to your refrigerator, and your refrigerator talks to your toaster, and your toaster tells Netflix when you're ready to go watch another movie, and yeah. So this group of companies is going to align themselves with Coca-Cola and Adidas, and the other federation is going to align with Nike and 7-Up, and that's where the fighting will begin. It's all because we have a lot of data. A lot of data. Zeta has 350 million people in our database. That's more than live in the United States, with 3,000 attributes about them all. How can they possibly know 3,000 things about me? Well, it turns out not that hard. Who am I? My identity. What I have in my history, in my record of stuff I've done that's been published. What I own, what I like, the things I've identified with on social media, what I own, what I actually do, behavior, and then the expressions of my opinion. That's a whole lot of stuff, okay? Which brings up another subject which I'm afraid we don't have time for. This is where it gets seriously weird. We got B2B, business to business. B2C, business to consumer. Get ready for consumer to business. So here's the premise. I am going to own my own data. It's not going to be owned by all the companies that I work with. It's going to be owned by me. I own it. So in 1948, the United Nations declared 30 human rights, which Humanity.co said, you know what, that was great, but it doesn't cover us today and certainly won't help us tomorrow. We propose a 31st human right, the right to legal ownership of their data as property, available to sell and barter with. So how is that going to work? Well, there's this group at Harvard that's been working on this for 10 years. So you've got customer relationship management, this is vendor relationship management, and it's going to work, first of all, like DNS does. And don't raise your hand, but there's probably one person in here who doesn't know what DNS is, so I'm going to explain. When you want to go to a website, you type in the URL and it goes to the root server that says, oh, you're trying to go to a .com. It sends you to the .com server and it says, oh, you want to go to Amazon? There is your website. It is distributed. It's not owned. It's not, it's designed to withstand destruction. So if there is a problem, it can route around the problem. If a router fails, the other routers can pick up the slack. And if we put together a system that works on this capability, it is distributed, it is not owned by a corporation, it is trustworthy, it is auditable. So how do you make this stuff auditable? Well, those of you who are playing buzzword bingo know that in every presentation we have to mention blockchain once. This is the time to do that. So it's distributed, it's secure, it's trustworthy, and I am going to own my own data, and I'm going to store it myself. Okay, well, that's kind of the opposite of what I'm doing now. I'm online and I'm using all of these apps. And every single app knows my username, my password, my phone number, some of them have my address, et cetera, et cetera, et cetera. And I want to just flip that around. And instead of them having all my data, where if like happened to me 2 weeks ago, the credit card company asked me if I bought new tires in Texas. No. Okay, we'll send you a new credit card. You'll have it tomorrow. And then I have to go to all these people and say, no, I've got to change my credit card. It's a nightmare. So let's flip it around and say that I own my own data. I store it in my own data pod and I keep it secure. And I update it here, and they don't own it, but they have access to it. I've granted them access. So this is the opt-in. This is the world where GDPR says, I own my own data, I have the right to transfer. I don't even need to transfer, just stop using that one, start using this one, because it's the data set here. And I give them permission to write to it what they need to know about me, different from everybody else. They can access, nobody else can, but it's me, it's mine. So you decide to where you store your data, in the cloud, on your own server at home, on your phone. It is separate from the app, so I can move it wherever I want to. I give people permission, and anything that is saved could be made available to others. So my data is always in sync. I don't have to go tell everybody that something changed, because they're all accessing the same data set. So how is this trustworthy? Well, there's this initiative called Solid, and one of the first companies that's trying to put it together is Interrupt. And how do I trust them? Well, maybe you recognize this guy. Tim Berners-Lee created the World Wide Web, gave it to everybody, done deal. Doesn't get money for it, thought it needed to be available to all. He's working on this. If he's working on this, and I don't trust the web in general, and he says that he's really upset with the nastiness and misinformation that's spreading, and that the web is sick and needs saving from companies and governments, I say trustworthy. I say that's the right mindset. So open source, available to all, secure, auditable. Premise number 3, I want my own data. And that's why I think this is actually going to happen. Because it gives me something I don't get anywhere else, which is confidence. I don't trust Facebook. Social networks put your privacy at risk even when you don't have an account. And of course, Google, oops, traffic ticket. Don't trust my government. I mean, Swiss government, I have no comment about. United States government, I absolutely have no comment about because I have a heart condition when I do. So nobody's trustworthy, but this is the big deal, convenience, because I will pay 15 times more for a cup of coffee than it cost me to make it at home. 12.5 cents to make it, or I can have somebody hand it to me and mispronounce my name. I will pay 15 times more for that. Because convenience is having to do nothing. I don't have to do anything. It's done for me. Amazon said, hey, you should subscribe to things. So I subscribe to this facial soap that my wife loves. I live in Santa Barbara. There was one store that carried it. They don't carry it anymore. We buy it online. Every so often, 6 bars of soap show up at the door. And if I have too many, I dial it back a little. And if I have too few, I dial it forward a little. and I adjust how often it just shows up. This is a water filter that I need once every 6 months. I can't remember that. I don't put it in my diary 6 months in advance, but Amazon does. Shows up on my door. Oh, time to change the filter. I have to do nothing. And now it's going to get really weird. Because I have my own data, I'm storing my own data. It makes life easy. And I'm going to put my own personal agent on top of that data and represent me in the world. Customer relationship management, vendor relationship management through an AI interface. It's my agent. It's not Google, Apple, Facebook, Twitter, or Amazon. It's mine. It knows everything about me. I decide that I'm going to give my accountant access to all my financial information, my doctor access to all of my medical information, not the other way. I am going to give Amazon access to some of my information, maybe in exchange for discounts. Maybe Amazon wants to know what I watch on Netflix, and if I do that, they'll give me a discount on Amazon Prime. Oh, okay. I'll sign up for that. And it works proactively. It says, Jim, there is a 90% chance that your dishwasher is going to fail next month. And I found 12 that will fit in your kitchen. Of those, there are 4 that will fit your style. Of those, there are 2 that will fit your budget. And one of them can be delivered next Wednesday when you're waiting for the plumber to show up. Would you like to install it on Wednesday? Yes, no. That is a service. It's mine. It's not for the benefit of Google. It's not for profit. It's for me. And to me, the value of that is so obvious that it is going to happen. It'll take some work, take some time, but it seems like it's a no-brainer. And then we get to shopping, and shipping becomes shipping and shopping. I expect someday I will get a box. And in the box will be 3 things that I was worried about running out. Great. 3 things I didn't know I was running out, but oh look, I'm running out. Okay, good. And 3 things I'd never seen before, but those are pretty cool. And 1 thing's like, no, send it back. And that's shopping. They will predict what I want, they'll send it to me, and I'll return what I don't want, and they will learn about me more and more and more by interacting with my personal bot. And it will be a good thing. I will like this, because I can trust it. I wanted to know if I need more milk and eggs. I wanted to know if I need to leave a little early to stop and get more gas. I wanted to know I'm going to have a dinner party and I need to stock up on wine and cheese. And I wanted to know that I'm going to be out of town for a while, so maybe I don't want to buy milk. And I wanted to tell me that it might be time to start wrapping up. It's smart enough to work for me on my behalf. It's not robot zombies with lasers. That's not what the robots are about. But it is about a new kind of tool that we will need to learn how to use. We'll have to get comfortable with it. It is about building our brand so that people ask for us by name and tell their agent to always order that kind of soap. And it's about building our systems that can talk to other systems. And you will always have a job because you have something that the machine doesn't. It has brute force logic and it has statistics. It doesn't have common sense, reason, empathy, the ability to look at something and think about how that applies to something completely different. You can do that. You will always be necessary to figure out what problem you want to solve, what data it should consider, and whether the output is logical and reasonable and okay. Because if the computer says, oh, you want more email opens? I'll send 10,000 emails to everybody every 10 minutes, and they'll open more emails. No. You're right, but no. You will identify the problem, you will decide what data should be considered for the model to be built, and you will evaluate the output. And that's why robots will never take your job. I hope that was interesting, and I hope there are questions. Thank you. And we lost Anna. I was counting on her to handle the tough questions. Yes?
How do I get to trust my personal bot? Because it's been developed by the Acme Corporation. We're getting a half of 1% fee on everything that buys on my behalf. And is it really working for me?
It is really working for you because it's open source software. So it's not built by Acme, it's built by community. And it's managed by Tim Berners-Lee, who's already proven that he is there for the benefit of society instead of the benefit of profit. And it's not owned by the government, and it's not doing things deviously behind my back by design. Other questions? Comments? Disagreements? Yes, please.
I love the C2B idea. I was wondering in terms of timeline, when do you think it will be come up in the day-to-day basis?
So when it comes to things on the internet, I have learned to always say 5 years. Because anything can happen. I looked it up last night at dinner. The iPhone came out in 2007. 12 years ago, we were all amazed, and now our lives are extremely different than they used to be. So 5 years from now, anything can happen. In other words, I have no idea. Yeah.
So a question about this data stuff, this storage of the data, or allowed other companies to take the data and work with them. So I have got an Android phone, and so there is possible to change which app has the possibility to take which data. But I don't know, not one person that's really changing this stuff.
Yes.
So we just agree and say, yeah, take this data, no problem.
Absolutely. Yeah, we all do that because the terms and conditions are this long, and I just want to get a restaurant recommendation. Thank you. Imagine if you are on the team that is building the personal agent as an open source device, wouldn't you want to build in a system that would help you choose your access levels? And it would learn about what your access levels are. And it would say, oh, you're going to download a new shopping app, or you're going to interface with a new shopping system. Would you like to give it your normal access, or would you like to look at special capabilities, or would you like to look at things that they'll actually pay you money for? It's like, oh, yeah, I want to know about the money thing. Okay, well, if you allow those shopping people to know what you're doing on Netflix, it'll give you $1 a month. And if I do that 100 times, I can go out for dinner.
So since the Hitchhiker's Guide to the Galaxy, we know that the ultimate answer to almost anything is 42.
Absolutely.
And as Douglas Adams correctly framed that, but what is the question? And the answer in the book was that, oh, for that we don't have the computing power yet. So my question to you is, how do we know that we are asking the right questions?
We don't. That's the human condition. Why are we here? Should I marry that woman 38 years ago? As it turns out, yeah, it was a good decision. That's us stumbling along through history, making mistakes. Going all in on the internal combustion engine instead of electric cars when we had an option to choose. And learning.
I wonder.
Here.
Excuse me. I wonder if you have an opinion about Article 13.
I absolutely have an opinion. What is Article 13? Which one is that?
No, and its impact in the future. So I think that a world where everybody is adopting some sort of Article 13 will be a much different world, right?
Mm-hmm.
The discovery process, understanding what people really want, is going to be hindered because people will not be able to create from the big products they have they are proposed, etc. So when you have followers, when those guys use it and reframe, reuse, resmash what you're doing, you have a much better idea how people are interacting. Article 13 is bringing it back to the big companies as far as I can see it. So I wonder how you see it. If it spreads worldwide, it's going to be a huge impact on marketing. Right?
Yes, a giant. It just turns marketing upside down. Advertising stays the same. put a billboard on the side of the bus to get people to tell their bot that you, but the bot is going to say, oh, well, we need some more dish soap. And the brand that my master likes is on discount at this store, so I'll buy it from that store. Or they make out a new formula that will solve a problem that I've heard him talking about with his wife, that the dishes are too greasy, and here's a better formula, so I'll go buy that and say, try this, see if you like it. Now, that means I still have to advertise, but how do I sell? Becomes the hard part. How does a corporation get data back so that they can do this analysis? They're going to pay for it. I'm going to give you 20 cents a month if you will open up certain parts of your data set to a conglomerate that will then sell it to corporations. It's like, no, you can't pay me enough money. Okay, what if I pay you $5 a month? What if I paid you $5,000 a month? Okay, now we have a conversation. And then over here.
Yeah, when you were mentioning the use cases on AI, I thought about just reflected last week and how often I was disappointed by the Netflix offer. I thought it was really crazy.
Yeah.
I thought about these weird product recommendations on Amazon and so on. So the question is there a really good use case for AI, or are there so many and I just don't see them?
There are very many, but they're not in marketing. They are in places where the data is more structured and the outcome, the desired outcome, is more clear. Marketing is the messiest thing we can find to apply this to. Because I want to put the right ad in front of the right person at the right time, and there is no correct answer to that. I want a solution for attribution, and I will never have an answer for that. It's dealing with humans. There's an AI company, anybody know X.AI? Anybody use that?
No.
Okay, good, a couple people. It is meeting scheduling. So I send you an email saying, let's get together for lunch next week. And I copy Amy at X.AI, and you and Amy have a conversation. Because Amy has access to my calendar. Amy knows that I don't like taking lunch on Friday. Amy knows that where your office is and where my office is, and so we need an hour and a half for commute time to get to the restaurant between us. So there has to be a day that has an hour and a half in it. Agrees with you, sends me an email, say, okay, I've added it to your calendar. The company is up to about 300 people. They've raised $80 million. They've been at it for 8 years. Scheduling, no problem. Emailing human beings, nightmare. Really tough, because humans, wow, we're messy. So marketing is a really tough problem to solve. If I want to increase email opens, that's a really clear goal. If I want to increase revenue, the machine tries lots of things and discovers that they sell 50 euro notes for 5 euros, revenue goes through the roof. Great. Oh, wait. We just ran out, we're out of business now. So good use cases, there are individual campaigns. I mean, that's the thing that I really have to bring the mind back to. It's not artificial intelligence. It's a single solution to a single problem. I want to sell more of these things. I want to run a special so that I can increase my revenue this quarter. I build a model, I try it out, I get the machine to run through a gazillion different models to make it sell, and we run the campaign and it works really well. That model is not useful for anything else. It solved a problem. Okay, so marketing is just so messy. It's humans and psychology. Yeah.
When you're talking about the ensemble, like putting all these technologies, it reminded me of a startup called datarobot.com.
Yes.
Are you familiar with what they're doing?
Yeah.
Do you know someone? Because just for the others to explain, is that you give them the data, they will try all these algorithms and just find you a model that just fits your data. And then for data science, just take it from there to optimize. I was just wondering if there are some other companies doing the same that you're aware of, and maybe applying something for business cases?
There are. There's an enormous amount of money in Silicon Valley looking for 2 students in a dorm room who are inventing new algorithms. All of these algorithms, all of these models are available open source. You can get an account on Microsoft Azure or Amazon AWS and play with them. And you can then put in a ton of data and test them for a very small amount of money. So if I wanted to start a business doing that at scale, sure, I'll charge you $1,000. I'll give Amazon $25. I'll run 700 different models and then recommend which one might work best for you.
And pack it under a product that costs $50K a year.
Yeah, yeah, business model.
Yeah, because then you rationalize that, say, hey, it's cheaper than a data scientist.
Absolutely. So I'm going to look at the big guys who are doing Sensei and Watson and that I'm probably already using, and I'm going to look at the startups that are looking for companies that are willing to partner on help us build our startup. And you should do that, but you should think of it as a learning experience rather than a business solution, because startups are wacky by design.
Is there a reason why on the list of the big players you didn't name Microsoft?
Lazy. No reason.
I thought you were biased.
No. Microsoft, Azure ML will be on the next version of the PowerPoint.
What would you recommend to someone who is in marketing, like has like some knowledge of numbers, but they want to get deeper into AI and to go into analytics part? What would be the first step?
Coursera.
Better than data camp?
To start with.
Okay.
Yeah. So then you can ask everybody, so I've done Coursera, now what do I do? And it will be, well, tell me more about what you want to do, and then you get pointed in different directions. DataCamp might be one of them.
But where do you start, Steph? Like, you hear about Python, you hear about R, you hear about like random forest.
Yep.
All of it.
Start at the beginning. We're at this weird point in time. So, data scientists, I'm sorry for this, but I think the first job that machine learning and AI is going to take away is data science. Because the machines will be able to do machine learning better than humans can. Applying that to a business problem is the hard part. Because it's, do I have the right data? Is the data clean? Does the problem actually move the needle? Will the answer to the question actually change behavior of the organization? Do I have corporate support and budget? That's the messy human side. And data scientists, of course, spend 85% of their time cleaning data. And they spend 5% of their time doing analysis and building models. They spend 10% of their time complaining about the 85%. Because it's a mess. Data's tough. I want to thank everybody for coming, because you've been a wonderful audience. You can tell I really enjoy presenting. I hope it's been useful. I hope it's been educational. And I am eminently findable online, so more questions, please feel free, or corrections, please feel free to let me know. Thank you all.